All right, are we locked in? Are we locked in? We look locked in. We could be more locked in. Okay, that's fine. Uh, we already did discourse on that last week. You were otherwise engaged. Um, who loves data structures? Yeah, right. Did we not go over this last week? Okay, so Wits gave me this device and I was going to put Linux on it, and I don't have a single USB drive to my name because I'm like a cloud engineer and I don't believe in having physical hardware. So I went to put Linux on this and I was like, oh, I like have not seen a thumb drive in 10 years. So yeah, I'm normal and was gonna use like Debian or something, right? Okay. Mint, something a little normcore, a little approachable. Right. Remember, I have to plug this laptop in the like at the end of August, and a bunch of first years have to see my desktop and not get freaked out and change to data science majors, which happened to Indy, by the way. Um, so um, anyways, I have not activated Windows because I was going to put Linux on here. Then I realized not only should I probably not do that, but I also couldn't do it. But by the time I'd done that, I'd been completely locked out of my legal version of Windows. So I rootkitted the thing, and this is an illegal copy of Windows. Now, for those of you that don't know, if you don't pay for Windows, it doesn't activate OneDrive or Copilot, the two worst features of Windows. So actually, this is the nicest version of Windows I've ever used. Yeah, but then I'd be stealing valor, right? Sure. And so I got it to go away for a while, and then it came back when I edited the registry. Cool. So I need a shell script to run in a cron job in my WSL partition. Okay. Yes. That's cool. This one just woke up, so that didn't work on me. Do you have 10 or 11? Okay, I got it to work on 10. This one's 11, which I don't know how. It was also harder to break into it. But you'll figure it out in a week, right? Or whatever. Thank you. Anyways, if you have additional comments on my operating system, I don't care. Okay. Today we are going to learn about data structures. This is the second and final repeat lecture from CS 271 last term. Both of these are Voltron lectures, so there's actually 4 total lectures that I've combined in the 90 minutes. Because last year they were done at the beginning of the term, and now they're done after UNOC. So it's not too bad. But I'm going to have to introduce some terminology, and I'm going to teach you about structs. I'm going to make no reference to something. I'm going to tell you I'm not going to make reference to it now because I think it's academically interesting. I'm not going to say the word record today. The term record was introduced as a way to describe certain subsets of data structures that only contain data but not contain methods. So there's like a record type. Increasingly, records are stored in hash tables, so Python dictionaries and JSON, right? If Eric Roberts were here, which he's not, right? He made a strong impact on this department and then wandered off into the sunset. He would want me to talk about records today, and I'm making the design decision not to do that because I don't find that distinction academically interesting. But if you're super into historical abstract data types, these structs are records. That's what they are. Okay. And with that, let's get motivated. This is the best single by Normani. Okay. Any Normani appreciators? You have no culture. Okay. Disgusting. Thank you. I respect that you're nodding slightly. Okay. C contains a language mandatory data clump anti-pattern. Do you all remember this? Okay, it's length prefixed. Okay. Nothing wrong with length prefixing. I do have a problem with specifying it this way. All right. Okay, so that's bad. And this got worse over time when character stars got bigger than integers, right? So now it's exceptionally bad. We can fix this with malloc, right? And this is the way I have proposed to fix this thing with malloc. Okay, so what are we doing here? We have various steps. argc is the embiggifiedness of argv. It's how embiggened it is, right? Or perhaps how large it is. Its size, right? So we need both of these things. So I've created a void double star called both. What is a void double star? It's a pointer to a pointer. It is the location of a location. For example, if I say my email address is on my website, that is a pointer to a pointer, right? There's a where you can find out where something is when you go to another location and check it. Have any of you done like those like scavenger hunt things where you like find a clue to the next clue? Those are pointers to pointers, right? Have any of you ever taken the transitive closure of a binary relation? Obviously, right? You don't know. Okay, that's embarrassing. Okay. So, sorry, what I meant is add two numbers. No, I think I'm pro whole. Okay, never mind. Aren't we all? Okay. Um, let's strike that one from the record. Okay. Um, yes, I can. Chat, clip that. I said I wasn't gonna what? You got me, but I was not referring to the abstract data type, so it's okay. Record scratch, freeze frame. I bet you're wondering how I got here. I got here by malloking two void stars. How did I do that? I took the size of the void star. That's 8 on my computer, and it's probably 8 on your computer, but it might not be 8 on the RISC-V microprocessor that you use to do research for me this summer if I get funding. Okay. Okay, and then we multiply that by 2. Why do I multiply that by 2? Easy. I've got two little McDubers up here, right? A McDuber is, of course, Scottish for the son of Goober, right? So we have an integer and we have a char star. These things are not both the same size as a void star, but I'm trying to create an array of things, right? So I'm going to create an array of two of the same thing. The two of the same thing I'm going to create is void stars, right? Because the void star is how we deal with something that we're not sure what it is yet, right? So I create two void stars. I call it a pointer to a void star. So this is an array of void stars. It's an array of pointers, and I call it both. That's two of something. I've got two things. Okay, now I'm going to cheat. This is extremely illegal. You're not allowed to do this. I'm going to teach you how not to do this today, right? But this is the motivating example, right? Because we are currently Normani. You also record diamonds, right? That was another good one. Okay. I take the 0th thing at both, right? So what is this? Both is a location. At that location, there are two void stars. This is the initial or leading or 0th of those void stars. And what do I do with that void star? I do not put a location in that void star. Rather, I put a numerical value. That's bad, but allowed, right? I say, dearest both, how I love thee, please take this 4-byte integer argc and pretend it is a location. I will get back to you on why we do this in a minute, probably down here, right? Okay, that's the first thing I do. And then what do? I take a little walk. I walk exactly 8 bytes. And after I've walked 8 bytes, I am at the 1th location. The, I don't know, pen initial, after the initial location. Anyways, this is the final location. This is the 2nd of 2. And in that location, I take argv, which is a pointer to a character star. So, by the way, both is going to be a pointer to a pointer. One of those pointers is going to be a pointer. So this is triple, right? Okay, sorry. I'm not sorry. You can think recursively. Just figure it out. It's computer science, okay? You're all smart cookies, or perhaps what is something that is not a cookie? Biscuits. Yeah. Rabbits. Rabbits are also not cookies. Okay. Perhaps you are a smart rabbit. Okay. I'm getting back on task. Don't worry. I'm on task. Okay. argv is an argument vector. It is a pointer of some kind. It is a pointer to a character star, but we don't care about that right now. And we're just going to take that location and we're going to store it in both one. So I am storing the location of whatever this thing is, and I don't actually know if this is stack or heap allocated. I'm almost 100% sure it's stack allocated, but I did not check. So I'm going to store a stack location in a heap allocated void star thing, okay? Then what am I going to do? I'm going to call a function. Oh, I love to call functions, right? It's just like calling an old friend. Instead of friends, I have functions, right? And then I'm going to return 0 so the operating system knows that I wasn't up to any funny business, right? You don't want to get in trouble with the operating system, right? Okay. So we write a function that accepts a both. Why did I call this a p-vector? This is a length prefixed vector, which is the same kind of thing as a Pascal string. So I'm calling it a Pascal vector. You can read more about this on Jimmy Whale's own Wikipedia, right? Look at this. Oh, it's glorious. There's text. There's discussion of bits in UTF-38. Oh, it's the term record. Oh, let's get out of here. Get out of here. Okay, panic, panic. Okay, did everyone panic? Okay, you can not panic now. I got record off the screen, right? Okay, so what do we have here? I have a both. Avoid double star both. It took me like 10 years to remember you have to put voids double star in order for the type checker to not panic. So if your code doesn't work, it's because you have the wrong number of stars. Just add or remove stars until it works. A principled software engineer would probably tell you you're supposed to know how many stars things have. I don't know if that's true. I think once it becomes a void star, it shouldn't matter how many stars it is to me. But you should always cast. Okay, so we're going back to int, right? We're returning to tradition. And we're going to take the 0th element of both. And what do we put in the 0th element of both? Oh, I put an integer in there. I called it a void star, but it was just an integer, right? So I'm just going to say, hey, that thing that you thought was a void star, haha, I have bamboozled you. I've outsmarted you. I am far more powerful than you, silly compiler, right? That is actually an integer, right? And I'm going to store it as argc, right? I'm also going to create an integer I that's going to help us later when we write this for loop, right? Okay. So I have argc. I've extracted argc from both. Good job, bully for me, right? That's probably supposed to say both 1. Does that look like an error in my comment? That's a 2. Why is there a 2 there? Someone was writing code in the R project for statistical computation and then switched to this language, right? Vectors, they got me. Any R programmers? It's not unfortunate. It's a functional language. It's cool. Okay. So, what do we do now? Well, we create a character star star. Why is that? Oh, because we put a character star star inside of both, right? Both contains a character star star. Now, it doesn't know it contains a character double star, right? It thinks that thing's a void star because we've bamboozled it, right? So we're going to anti-bamboozle or de-bamboozle both 1. We're going to say, aha, I fooled you the whole time. Dear compiler, that actually was still a character double star, even when I told you it was a void star. I lied. And we're going to put that in a character star star called argv. Are we going to really put it there? No, this is really just a name of that location, right? So that's fine. Okay, then what are we going to do? By golly, we're going to print some stuff out. Everyone loves printing things, right? Who here is a big fan of the Gutenberg press? Yeah, right? That's what I thought. So good for all of y'all. I wonder if should I run this code? Do you want to see me run this code? Classic students wanting an example. Just intuit what it does. Okay. I was doing Heartbleed? That seems really dangerous. Okay. Let's just get rid of all of that stuff. Okay. let's do, what am I doing? I'm printing. Oh, okay, we'll call this both.c. Okay. Oh, we couldn't figure out how to copy paste into here, right? So I need to echo into both.c. Is that right? Okay, and then I need to echo this into print. Print the dot C. Is that what I called it? Oh, I called it print argv. Print the is fine. Okay, we'll cat print the. Okay, and then we can cat both and print the, and that looks like this. Oh, we want to change the order. Okay, that looks fine. And then we're just going to put that in both.c. And we're going to, nope, let's see. We'll call it boths, the plural of both. Okay. Then we'll vim both.c, boths.c. That looks fine. We have to include, what do I have to include? Standard io.h for print and standard lib.h for our guns and gold for our libertarians, right? Okay. Wow, no one's paying attention. How's it going? Everyone chill? Living the dream? Wow, that's a lot of errors. Does that seem bad? Wait, no, there's just 2 print args. That's so silly. Okay, cat both. Okay, I see what I need to do. We need to re-echo. Mm, call this main.c. Okay, that's fine. Okay, now we're gonna cat main and both into boths. Then we're gonna vim boths. Okay, that looks fine. No, main's first. I don't want main to be first. Okay, so we're gonna change the order. We're gonna do both then main. Vim boths. Let's see. Okay, that looks fine. Wait, how is my cursor there? Okay. We need. How do I mute this? Oh dear. That's not what I meant to do. How do I? What is this? I opened help. Okay. We're gonna include. What are we including? Standard IO for print and standard lib for malloc. This time it's going to work. GCC boths .c. Cool, not too bad. We need to fix something in line 10. Which one of these is line 10? How do I see line numbers in Vim? That? Thank you. So this is the issue?
There's no quotes.
There's no quote. Oh, the quotes disappeared when we typed or whatever we did. And so that's like one of these ones probably. Percent S new line? Is that a new line? Is that backslash new line? Is that right?
Yeah.
Okay. Is it forward slash? We like backslash. I'm trusting all of you. I'm gonna believe whoever I'm currently believing, which might be Olivia. So we'll see what happens. Okay. Oh look, it's argv0. And look at that, it's the first four numbers, 1, 2, 3, and 5, right? So I think that's the expected result. How unbelievably cool is this? This is so cool. I love this, right? We all love this, right? It's just cool. It's just good, clean fun, right? You be hanging out with your mates on a Friday and or Saturday night, right? And you could go play billiards, the devil's tango, right? Or you could write data structures in God's own language, C89, right? I do believe the universe is written in a stack-based systems language, unironically. Yep. Well, I mean, it's not that bad, but it's pretty bad. Okay, so instead of doing this with length prefixed void star stars, which you are allowed to do on list T, I'm not giving you any restrictions on how to do things on list T. This is completely legal. I'm going to teach you the sort of idiomatic way to do this. So if I were Shakespeare and I could only write in iambic pentameter, right, I would be forced to use structs, I think. Any Shakespeare appreciators? Do we love The Tempest? Perhaps Othello? Yeah? That's all I got. Okay. Yeah. Okay, so this passes both. That's bad. We're mixing 4 bytes and 8 bytes. No, not good. Okay, so how does this work mechanically and internally? Well, really what's going on is we're throwing these things onto the stack, and then we're just calling a function. And when we call that function, the stuff is on the stack, and it's on the stack, blah, blah, blah. We're stacking things up, right? Both 0, both 1, all stacky. Okay, and then we were going to put both, which is the void star star, on the stack when we call it to here, right? Now, void star star is just going to be a pointer. It's a pointer that goes to a location. We are responsible for freeing that, which I did not free. This is totally undocumented. You don't know what this is pointing to. I argue this demands a solution. Okay, here's the solution. We get rid of the data clump anti-pattern. Okay, so we're extracting the data clump anti-pattern here. We know what it is because we wrote this code here, right? So we have to extract. We're creating local variables. We're creating aliases. Oh, we have something called argv. Wait, we have something called argc and argv in the other thing. Like, look how bad this is. Both, like, I'm using this, like, forward arrow notation to note what's going on. That's print v argv.argc, which is a type int, right? I don't know. This is bad. This is bad. Okay, it's bad. Why can't we just tell GCC what the void star star really is instead of renaming everything to void star and back? And wasting those 4 bits and drawing warnings and. Ta-da. Struct. Okay, so this is the argv struct. What is the argv struct? Well, it contains an integer, which is called argc. It contains a character star star called argv. It knows what it is. It has a firm sense of self and a strong identity. It completed self-actualization, perhaps while working on its undergraduate degree at Willamette University, as all of you are experiencing right now. Can I get a whoop whoop for self-actualization? That's what I thought. Good job. Yes. Hold your heads up high and or don't. I don't actually know if that's good or bad. Okay. Struct. Argv struct. Why did I call it that? I put struct everywhere so I know what it is. Okay? It is semicolon punctuated. See? Semicolons are doing line breaks, and it also has a semicolon at the end, right? That's how you tell that this code block is not a function, right? Okay. It is named. It has a name. Its name is struct argv struct. It's code block because it's enclosed in curly cues, right? These are Arby's curly fries, right? Okay. They're not, so I went to a Burgerville this weekend and the fries are mid? What is up with that? I thought it was like our local state burger joint. It has mid fries. We're Oregon. We're like a potato economy. Oh, do those slap? Okay, all right, I'll go back. It wasn't dirty enough. Like, I've never been into a Burger King that, like, feels comfortable. Well, I went to Burgerville, right? And it was, like, clean. And I was like, this is disgusting. I just start trashing them. I had an Oregon strawberry shake, and it was also, like, it didn't go through the straw that well. I was in shambles. Okay, common problem. Yeah. See, I think if you want a drink, you go to Dutch Bros, right? Bros before Burger Villos. Okay. Based on the struct keyword, right? That's a struct keyword. You're all familiar with keywords because you're all Python programmers and you think it's reasonable to call things def, right? Okay. This contains only variable declarations. There is no actionable code in here. I cannot write a line that does something. I can't write an assignment. I can't write a function call. I can't write an operation. Okay? No executable code. We're not executing. We just are being. We're sitting with ourselves. We're focusing on our self-actualization, right? The world is passing over us and by us, but not through us. This is a noun and not a verb. Okay. Boom. Motivation. I'm going to introduce 2 terms. The terms are declare and define. Here's how we do it. Okay. Now, more so in Portland than here, I've been getting roasted for using .h files without explaining what they mean. But you all know what header files are, right? Header files are where you declare functions but don't define them. You say, hey, I have something that has this name and this type, and if you want to know how I wrote it, you have to look at the .c file, because it's none of your gosh darn business how I add 2 496-bit vectors together, right? You should have your own problems to worry about. Go touch grass, right? And so that's what we do with 496t.h. It's easy to send this to our friends and be like, hey, I wrote this library. Here's the descriptions of the library. Don't worry about the contents, right? So in 496t.h, we specify a name, a function type, and no executable code. We call this declaration, okay? We're declaring this. And we are also going to be able to declare structs the same way we declared functions. We have also declared variables. Here's an example of a variable declaration, int I. Not defined, just declared. There exists some integer called I. It has no value. It just exists. We'll deal with it later. Okay. Then we can also define. I often think of define being in the context of single equals assignment for variables or in the context of writing code blocks for functions. It is unfortunately the case that we declare structures with code blocks and then defined them with single equals assignment, so it's a little bit goofy. That's okay. Functions and loops used parenthesized code blocks or curly-cued or shoestring Rosemary Burgerville fries, right? So they use the non-entry level bracket, right? So not just these ones, but like these ones. Okay. Um, and in the context of these definitions, we can specify a series of actions, which usually is going to involve setting variables equal to some value, right? Can include declarations and other definitions. So these are code blocks. Okay. How do we break this out? Okay. Declaration is useful in the context of the stack because it reserves stack space, but it doesn't necessarily populate the stack space. So we can ask for a void sum function that is going to say we need some undefined amount of stack space, and the stack space will be figured out later. We can ask for an integer, which will reserve 4 bytes on the stack, and we can ask for a character star, which will reserve 8 bytes on the stack. Now, once we have reserved those bytes on the stack, or borrowed those locations, or made sense of all of that, right, we can also define those values. So my sum func doesn't do anything. It's not very funky. Okay. I like that. I like the forced laugh. That's the correct kind. Okay. We put a 0 inside of this integer, so we have 4 bytes here, and we have zeroed out every single one of those bits. And then we create a local string called defined, and we place the location of that in the stack location. Yes, Cass.
Is that semicolon in there echo or is
This one?
Yeah.
Oh, you're allowed to have empty lines that are semicolon punctuated.
here?
I was trying to emphasize that there's nothing in this function, and that was the stylistic way I converged at. Another thing I could write here, for example, I could say, what was it? Void sum func. The thing I always do in Python, because I didn't learn about pass, is I just say 1 equals 1. And so that is true, but it doesn't matter. So this is clearly nothing. And the hope is the compiler is not going to like check to see if 1 is equal to itself, right? But maybe it does. Did that not save? Cool. All right, we got some vocabulary out of the way. We know about definitions and declarations. Is there like a Declaration of Independence joke? Anyone seen National Treasure? Okay. In a way, Nicolas Cage is a struct. Okay. All right. Ooh, that's a little aggressive. Okay. I did refer to object-oriented languages as less than. But I didn't mean it. It was all in good fun. Me and object-oriented languages go way back, so we're buds, right? I just the other day said Java was a good language, right? It's my LinkedIn profile header. You can look it up, okay? Right? Yeah, it is. I know, right? Who loves LinkedIn?
I couldn't tell if it like for the image.
My favorite Microsoft product. Okay. Look. Java. It's better. Okay.
I lied once.
Okay, yes, but this is the lie. The lie is that object-oriented languages are lesser. Okay. So why do I have extreme beef with object-oriented languages? Well, I think from a language theory perspective, I think it is cognitively easier to program when you have firm separation between data and compute. And classes put the data and compute in the same place. I think that is confusing. And it's not so much offensive to me that it's confusing as I think this confusion causes people to write low-quality code. And the specific low-quality code I'm thinking of is how many lines it took ASF to implement Hadoop MapReduce, which is like a very specific code base I care a lot about, and it's hard to read because it's object-oriented, right? So that's really the like beginning and the end of being annoyed by this. But every once in a while, some unfortunate undergraduate professor of computer science is assigned to teach a class called data structures. And frequently now in 2025, they're assigned to do this after students learn in their first semester C++, Java, or Python. And none of those languages have structs in them. C++ does, but it's borrowed from C, and they all have classes, right? So what you're left doing is explaining to these poor undergraduates who don't know that they've been taken advantage of by Sun Microsystems that they don't actually have structures. They have this thing called classes instead, and they're just sort of supposed to wave their hands and pretend it's the same thing. Right, so here's an example of me writing, I guess the indentation's wrong? I don't really remember how to write structures in Python. Do you all have to write classes in CS 151 and 152?
Yes.
Okay, all right, so presumably I taught someone how to do this at some point. To me, I am uncomfortable calling this a data structure. I would call this a computation structure, because what it actually contains is computation, not data, right? And so this is multi-add. This just adds n values together. I think the indentation is incorrect, so I can't actually demonstrate this. And there's no way this is allowed, right? Yeah, indentation error. Sad. Okay, so I'm not gonna figure out how to do visual block code edits right now. Okay. Right. So to me, this is a pretty reasonable thing to implement in an object-oriented language. You have an ordered pair. It has a leading and trailing element, right, which I call x and y. And maybe you want to have some representation functions for them. You have to have an initialization function. But fundamentally, something that I do not love, only for theoretical reasons, I think this is completely fine for software engineering, is that when you're teaching this language, it is unclear how to understand the difference between data at rest, data that persists in memory and storage somewhere, and actionable code, which is instructions running on the processor that have some sense of time, right? Init occurs at some point in time, and it creates self.x and self.y, but it's unclear when those are stack allocated. It's unclear where on the stack they would be. These matters confuse me, and these matters make it very, very difficult, I would argue impossible, to write an operating system in Python, right? There's more to life than writing operating systems, but it would even be hard to write one in some of the mature languages like Go or something, right? Pretty much need C for that. So in C, what we have instead is we just have structs, and structs only contain, we can think of them as values, right? X and Y in this location. So this is the ordered pair, and I think this is cool. I think this is good. I think this is relatively easy to work with. Right. So I think the compiler gets to decide what order the things actually exist in your struct in. And I think this usually happens if you ask for an integer, then a pointer, then an integer. And why is that? Well, an integer is 4 bytes long, and a pointer is 8 bytes long. So you would have 4, 8, 4. That's awkward because you have something of length 8 that is offset by 4 bytes from its address. So I suspect in that case, the compiler will reorder the integers and put them next to each other. Really, you're not supposed to assume they're in any particular location. Now, when we used our data clump with our void star, we put things in fixed locations and we knew exactly where they were because we were being bit precise. We are no longer going to be bitwise precise. Rather, we are going to trust the compiler and use names. This is de facto getting very, very close to being a hash table, right? And it's not a hash table, it's a record type, but nevertheless, it's getting quite similar. So, using our malloc motivating example, we're going to go through this and we're going to address this with structs. What time is it? How fast am I? Am I talking faster than normal today? Really? Okay. I'll listen to some really, really hypey music on the way down here. This is Amity Affliction. I'm wearing the sweatshirt and everything. I've completely changed my personality in the last 9 days. Did I tell you I locked myself out of my apartment after the Amity Affliction show and had to sleep in my car? It was awesome. It like really added to the sad vibes. I was like, I'm so sad, right? And then you get to sleep in your car. It's awesome. Always lock yourself out of your apartment after a concert is my recommendation. Okay, so here's the alternative. Let's once again copy paste this into a .c file through the command line. Oh hey, we have Python. Wait, this isn't in WSL? Yeah, it is, right? Okay, so how are we going to do this? We're going to, what's this thing called? Argv. Okay, so we're going to echo into argv.c. No! Okay, something broke. That looks extremely broken. Like, more broken than normal. Wait, why am I typing exit? Okay, I'm cheating. Am I? No. Okay. Um, hey, it's Winks. Am I actually in WSL? Okay, I don't know what's going on here. Vim arg.c. I can't get it to copy paste. Okay, so if I were really clever, how would I do this? So I have text in my Windows OS paste buffer, and I can get it out with Control V, but Control V also does a visual block change to Vim, so I can't use both of them. Like that? Okay. Oh, in insert mode? In visual block? Wait, what? I don't know the names of the modes, by the way. REG? Oh, okay. What is that? Oh, that's ancient. It's just like a little too weird to get it to WSL, right? Okay, I'm gonna save this in downloads as arg.c. Oh, it's all caps. That's unfortunate. Okay. Um, okay, there's something called args.c. Okay, so I'm gonna move mount c users Calvin downloads arg.c. I should have copied it. Oh, that's fine. Oh, that's cool. All right. What's going on here? So what I did there is I mounted the Windows file system onto the Linux file system, and then I moved something across the file system boundaries, right? Which is virtually identical to moving things across container boundaries if you have the container mounted, right? So we've seen that before. So what does this do? I am going to load things into the argv struct, which I've created here. It has an int and a character star. And I'm going to show the location of everything in it. And so what is that going to be? That's going to be the location of the structure, which I'm calling args. It's the location of the count, which I'm calling argc. And it's the location of the vector, which I'm calling argv. I'm going to print both of those things. Okay, what's going on here when I look at this? Well, the location of the structure, in this case, in the first case, this is in main, is at location 40, an offset of 40 from somewhere. And that is the exact same location as the character. So what does this tell me about the internal implementation of structures? It is very similar to the void double star case. The first element, or the initial entry in a structure, is at the same location in memory as the structure. In this sense, they're the same as arrays. They are essentially labeled arrays, right? And this thing is 8 later. Why is it 8 later? Well, I'm guessing because V is a void star. Well, it's a character star star. It's a pointer. It is of size 8. So it is getting an address that starts with 8. We're just throwing away the 4 bytes that are after the end of the integer c, argc, which contains the count. So in practice, this is logically identical to the void star solution, right? I'm creating one location, and then 8 bytes away from it, I have another location. I store a pointer in the second of those locations, and I store a count in the first location. This is the exact same thing. Now, one other thing going on here. These are stack allocated, right? Why is that? Because I am declaring a struct, I am not mallocing. When I declare that, it goes on the stack, and the stack knows how much memory it needs because it knows how big a struct arg is. This struct arg I would expect to be of size 12, but it is acting like it is size 16, right? We're throwing away 4 bytes to have things line up a little more nicely. Okay, so these things are allocated on the stack, and that means that this is a different instance. This is lower on the stack. We've pushed it down on the stack. Why is it lower on the stack? Because there's all this stuff on the stack ahead of it. And so down lower on the stack, we have the argv struct, which is passed to print argv. What this means is there is data duplication. There's an anti-pattern that's going on here. This is copy on function call. What does this mean? If things are getting copied on function calls, you should be very careful about how big your arguments are, and you probably often want to call things by pointer, right? So that's what I have for this. I hope that makes sense, and we can do some of this nonsense as well and see that roughly the same things are happening. I hope that all makes enough sense to you. These structs are so close to just being void double stars, okay? The nicety of them is it makes your code easier to read, and you get to refer to things by name instead of having to remember address. To me, that is almost identical to the use case of a dictionary, right? Even though a dictionary is a totally different thing. Okay, here's the example. We can examine this just as we did at the command line. And our takeaways is that this is the record theoretical type. It has been displaced by JSON in modern scripting languages, and we still use records that are basically implemented as arrays in systems programming languages. So if an operating system needs to pass around a bunch of information together, it's going to throw it all in an array. And if a web server is going to pass information around, it's going to load it into a JSON object and distribute it as text data, right? That's just sort of the way the world works, as far as I can tell. Okay? This slide contains a reference to the difference between compile time and run time. When this code compiles, which means when it is converted into an executable, that executable knows how far all of these structs are from each other and how big they are. It is all defined at compile time, and it can do absolute locations with precision next to each other. There is no mallocing going on here, right? So this is completely memory safe. If we were to use JSON, right, JSON objects are editable, so we would not have the performance benefits of that. In exchange, we would get flexibility benefits. So if you can plan ahead and think about how many bits you need, you can get higher performance code at the cost of having to know in advance, right? These are pros and cons, and they are just different design decisions. Okay, that is struct. Okay. I find it annoying to write struct argv struct all the time. Fortunately, there is a built-in solution for that. It is the type def keyword, where we define a type by some name. So I changed my struct argv struct, and I get to refer to it as argvs, or I could have called it probably args, right? I didn't call it args because I'm using args as the name of the variable, right? Whenever you are naming your structs, for example, you probably don't want to name a struct X or I because you're most likely using that as variable names, right? So just avoid namespace collisions and make your code clear. Now, I'm pretty sure I can put args in both of these places and the compiler won't care because it can keep track of them, but I cannot. So I'm encouraging you to look out for that. When something is a struct, you probably want to know that it is a struct somehow. I'm using _s, or more likely _t, as in the case of 496t and list_t, to denote that. I am adopting the convention of libgmp, which is the canonical library we've introduced in this class, where its struct is referred to with mpz_t, right? So we're just following them. That's not necessarily the most common implementation. Who loves Booleans? Any Boolean appreciator? Oh, is that a question, or do you love Booleans?
This is the question.
Okay, cool. What's your question?
So you said the
Mhm.
but like the main advantage is you can do games with them, but like you can also do like nameless stuff, right? Like
Yes.
what is the point of this?
So the real benefits that types give me, in my mind, in C, is making sure that the operators you use on the entries are the correct operator. So this is the difference between saying something is signed or unsigned, or is a float or an integer, right? So usually I'm going to be printing things out with format codes, or I am going to be adding them together with addition. Both those format codes and addition are defined by what I say the type is, and they're defined different ways for void stars than they are for ints, right? So typing is sort of this thing that's in between programming the compiler to treat variables a certain way and documenting your code and making your life easier. So it's both a compile time and runtime construct in that sense. When I say names, to me, the name is including both typing information and the alias, right? I am sort of not as opinionated on aliases, and I generally actually have a preference not to use aliases because I find it confusing to remember what they are. I'd rather use indices, but I always want to know what type of information I'm supposed to be thinking of my bits as at any given time. And that sort of elevates the information to data and then lets me use it as a data structure, right? It is all just bits under the hood, but even though it's all bits under the hood, I usually have something I'm trying to do with the bits, and I write it down. Okay, this implemented bool. As you all know, false is spelled with 4 letters. I take heat for this every semester. You do not need a silent S at the end of something that causes it to be a different bit length, okay? That's annoying. Just don't do it. I have like a completely unrelated tirade to go on about this, so just buckle up. Sorry. Here's something that's very interesting. In C, you cannot refer to things before you defined them. I'm using the term bool here, and I'm defining it down here. Why is that allowed? Well, actually, these code blocks occur after this type definition. Why is that? These defines are read by something that we've called the preprocessor. This is the thing that defined our macros, right? And they are used with something that is very, very close to a simple, naive find and replace operation. So when the GCC precompiler sees this, it does not look at this code. It is just treating this as textual data, right? So what happens is later on in the code base, somewhere down here perhaps after the type def, it will see the word true, it will perform a find replace operation, and it will place a Boolean casted 1 at that location. But at that location will necessarily be after the type definition. And because it is after the type definition, that means the term bool will be defined at that location. I would like you, like at a high level, and I'm not going to test you on it because I think this is a miserable thing to think about, to get a sense for thinking about what order you can write your code in. I wrote this by accident, and then I was going to fix it, and then I realized I should tell you what I did, because I think it's academically interesting. This code is sort of... Okay, I'm going to say something, you're all going to hate this. Or some of you are, because you know what it is. This is lazily evaluated. It is not evaluated at line 1. It is evaluated later, when true is written, but it is in another way the negation of lazily evaluated, in the sense that this runs before runtime because it runs at compile time, right? So this is compile time lazily and runtime, I don't know, real time evaluated, right? Does that make sense, Jimmy? What do you hate that? Right? There's I don't know a graceful way to refer to this, right? But that it is very, very close to being lazy evaluation. Okay. All right, header techniques. Oh yeah, I've definitely been yelling and talking faster because I'm more out of breath than normal. My blood oxygen level is lower. Should we do a stretch break? All right, everyone do a stretch break because I have to go to the bathroom. I'll be right back. Okay, and just look at this code while I'm gone and think about it.
Yeah. And they still persevere. Still persevere. I feel it's great. It's also frustrating. It's like, I know, but also this feel like it feels like people of that they're giving names. People don't like sense. Touch that. Yeah, it's good morning stuff. Oh, and John thought was here's my I feel the trauma.
So myself, what is this? That's really.
And all that Struct stuff makes sense. Really?
Like, I feel like I already knew how to use structs and I didn't know it. But, I mean, I think I got the conclusion.
Yeah.
No. I,
It's easier, much easier. I think. Let's very simple problem. But it's a little bit too easy with character to be like, why don't I just always use two variables? With lessons, it's like, why don't I always use an arbitrary number of variables? If I had to like, oh, right. Okay. Let's do some header files. Getting and setting methods exist. They exist for a reason. Maybe they protect you from things. Maybe they're a hassle to deal with, right? I had a lot of fatigue from working with them from CS 151 because I think oftentimes in CS 151 it's difficult to get levels of complexity where it's necessary to use getter and setter operations, right? But it's also good practice to start using them early on. Now, my opinion on getting and setting operations has changed a lot with the advent of GitHub Copilot and other AI code generation tools, because I mostly found them tedious to write and maintain, but they are trivial to write and maintain. A robot can do it. So actually, I think this is a very, very good job for something that is not a human, right? And so I very quickly just told a not human. This was probably Gemini. This could have been Copilot. I was like, hey, I need a pair class in Python. And I bet this just works. Let's see. Ah, not too bad. Oops. Yeah, it seems fine, right? It doesn't have a representation function, but that's okay. So if we set p equals to pair 1, 2, right. So you're not supposed to look at the x, right? You're supposed to say get x. Do you all remember this from your favorite object-oriented class, right? Makes a lot of sense to do this if you're an Android developer and you don't want to work directly with interface objects because they might be being maintained by someone else, right? Things of this nature. Okay. I hate this. I think if you want something to be private, you should enforce it. And how do we enforce privacy? Well, we actually use this little thing called cybersecurity. But you should at least if you type this, the interpreter should like ruin your day, right? Like, I don't know what it should do. It should probably throw an execute and recruit the operating system to shut down your executable. Now in Python, it just lets you do that, and that's fine. And I know what you're thinking. You're thinking, Professor Calvin, you're such a honk honk silly goose. You should just use double underscore, right? So we can have secret pair. This secret pair is, of course, I think we were talking about Shakespeare earlier. So this is Romeo and Juliet, known secret pair, right? You got the, shoot, what are their last names?
Montague and Cap.
Yeah, the Montagues and the Capulets. I was going for the Amontillados, but that's a different author. So you can have it's self, not this in Python, right? Self dot, you can do double underscore x. That's an int. That's also an int. Really? Self is not defined? How does, I was sure that would work. Don't love that. Is it just, let's see, double underscore net? Okay. Okay, fine, we'll do it this way. Self x equals x. Sure, we'll both specify its type and semicolon terminate the line. Dang it! Ah, it almost let me do it. Okay. What am I doing wrong here? Okay, so that's allowed. That's not allowed.
The ants.
Oh, it's over here? Real. Okay, then the semicolon's here. Well, this is starting to look like a good language. That's because it's Go. Okay, okay. Okay, and then you're like, all right, I've got you. We have secret pair. And the secret pair is, of course, what are our favorite two integers? Romeo and Juliet. This is a known type safe language, right? This is definitely allowed. See? The integer Romeo. Okay. In a way, isn't Romeo just an integer, right? I think we've all been there. Anyone know? Okay, all right. Then you're like, oh, we finally got an attribute error, right? You definitely don't just do like, I don't remember what it is. Do I put like secret pair here? So like, yeah, that's super secure, right? Obnoxious. So I picked my favorite programming language, which is Java. I have always loved Java. I think extremely highly of it. I think it's the best language, and everyone should be required to write all of their code in Java. And the reason for that is because it actually has public and private attributes for variables. So I didn't write this myself, but I did get it to run in, of all things, a Podman container, which was a really strong justification for Podman. I didn't want to install the entire Java toolchain, right? But it was very easy to install the OpenJDK, which is sort of the Java developer toolkit, right? And just run this quickly. It turns out Java also has a interpreter command line now, so you could just use this at the command line. What's going on here? Well, same sort of thing going on. We have class private pair and public pair, conspicuously similar to class secret pair, right? Exact same notation. But we have code blocks, right? Java's using C-style syntax. And so then we have public int x. So this x is visible within the class. This is a public class. Both of these classes are public, actually. And in this case, we have a private int x. So it is illegal. It is against the law to access this x. And actually, Java will protect this. I don't remember how it protects it, but it does. All the other code is the same, right? We just have public interfaces. So we want it to be able to publicly get x. And then I think the other thing that's kind of interesting is I guess Java uses, this is camel case instead of snake case, right? And I'm sure that's just some sort of social convention. So anyways, I thought I'd show you some Java. This is something that I think Java deserves a lot of credit for. The two things that Java has that I think are the best are publicity and privacy. And then also it has interfaces, and interfaces are very cool. So we love encapsulation. Did I say that correctly? Okay, that's what I said. Cool. We love encapsulation. Here was something that a few people brought up. on 496T do you have to have the most significant word, right? The most significant 8-byte chunk? Does it have to be first or last? And the answer is I don't care. And I'm concerned that I didn't actually implement some of the testing operations in a way that allowed you to make that design decision. That should be abstracted. You should be able to change that later for performance reasons or any other matter. It may even be the case you want to see like the middle bits first or something. That's totally fine. That doesn't offend me at all. There's a variety of reasons you might want to rearrange the bits in a 496T to, for example, work better on a GPU. If you're doing some like CUDA or something and you want to accelerate these operations, maybe it's very important what order they're in. I don't know. Doesn't affect me, right? All I'm asking for is this level of precision. In fact, if your 496T took up 6,000 bits, I wouldn't know or care, right? I would notice my memory footprint is slightly larger if I were doing performance evaluation, but that's the only time it even come up. So you should not write code that assumes endianness because someone might try and run your 496T library on a different operating system or something else. We got the impression that maybe some of the Apple devices might have different endianness, but we're not sure. It's easy enough to check, but it's like, why bother? You should just write generalizable code. So somehow we need to have some form of privacy, and we're going to achieve this privacy with header files. This is really hard to put on slides, by the way, because you use a lot of space, right? So I'm trying to write very brief lines and use very minimal examples and trying not to get things trailing off the ends. But I'm introducing to you this exact format. This is the same format as the list T assignment. Ooh, that should say .c. On list T, there is a list T.c that implements the list T. There's a list T.h that describes the list T, and then there's like a tester or an assessor or an autograder or something. That's the client. There's something that uses list T. Here is an example. We have our client. This is the person that paid us to write the library, and usually that's us. We write libraries for ourselves. It has main, and only one of the files has a main in it, right? This main function declares a struct, defines a struct, populates the struct with values, and then it returns 0 to indicate there were no problems. This is just a simple testing script. Pair.h declares the struct. This is a struct declaration. It is semicolon terminated. There is no actionable code in this file. And here is also a function declaration, right? This returns a struct pair. It's called noop. And this is semicolon terminated. There is no code block for this function. There is a code block for the struct, right? Over here in what is supposed to be pair.c, sorry, my bad. C's and H's, hard to tell them apart. We have the definition of noop. It creates a pair. It sets x equal to 0, y equals to 0, and returns p, right? So that is a way of initializing. So essentially, after this line, p will have 2 zeros in it, and then we'll set one of them to be 1 and one of them to be 2 times 1, which is 2. Okay? This is pretty similar to Python modules, and it's also relatively similar to standard libraries. I would encourage usage of a makefile when you're working with things of this complexity. 3 files, that's a lot of typing, right? Write them down once and then type make, right? This uses GCC or Clang. There was a discussion about Clang in the Discord earlier today because someone was writing Rust. It's really hard to stop the kids from writing Rust these days. It's a little bit too cool. If you want to write an operating system in Rust next year, take my class, and we'll find out if I can write an operating system in Rust. It seems quite likely that I can. And here's your C flags. These are the flags that prevent you from writing Rust, right? So, good for us. So Rust is named after... do I have anything for this? Iron dioxide? Yeah. Yep. There's a video game named Rust, right?
Yeah.
What?
An angry game.
Oh, it's angry?
A very angry game.
Well, that makes sense. I would be angry if I were a video game. Okay. So, here is how we do privacy. And this doesn't work, but I'm going to show you how to get it to fix, and I'm going to motivate how it works with this example. We might want to struct pair p, we call noop, and then we set x equal to 1. In order to do this, we declare struct here. We don't declare the struct here. We declare noop, and it returns a struct pair. Then over here in pair.c, which is once again mis- Oh, I remember editing this line. These are wrong because I didn't save my file after I edited it. Because I remember fixing this new line. Okay. We have pair.h. We declare the pair in this file, and we define the struct in this file. And we have 20 minutes left, so I can show us all of this. Okay. So, what's our favorite, like, Shakespeare? That's okay. Fair enough. You know what ruined Hamlet for me was Lion King.
What?
So, like, I like decided to make a large part of my personality hating Lion King because there were a lot of Disney kids when I was growing up.
Sure.
And it's just Hamlet, right?
Yeah.
And so then I was like, I spent years training to hate Hamlet before I read it for the first time. Yeah, and so like Hamlet did feel good to me when I read it, right? But it was like it was too late. So I'm blaming the Walt Disney Corporation for me not liking art, which that feels very reasonable. Let's echo client. No, we'll start a bit earlier. Ooh, not allowed. Okay. We're not going to use the makefile then. That's fine. Okay. So we're going to echo. This is client.c. There it is. Okay, we're going to grab pair.h. Echo. Do pair.c. Do we have... There we go. I'm going to remove the makefile. That's not serving me right now. Okay, and then we just gcc pair, and client. Okay? Really? That's extremely broken. Oh, some of these things broke. Client.c. Oh, I lost my brackets in transit. Wait, no, those should be quotes. Those should be quotes. Those shouldn't be brackets, right? Because I wrote pair.h. So by convention, those should be double quotes. Okay. And that's why they disappeared, right? Okay. Trying to find the double quote key on my keyboard, which is not really going well. Okay, and then vim pair.c. Okay, this has the same problem. Yes. Okay, that is what it is. What's everyone's favorite fruit?
Watermelon.
It's the pear. Gotta keep up. That's fine. Yeah. Look, it works! Good for us. Okay, so then what changes are we going to make? Well, we're going to vim pair.h and pair.c, okay? We're going to yoink. See, we're going to, is that gonna work? Did that go too far? Wait, how do I cut? I only know how to copy. The Vim power users aren't paying attention. I don't know. We're doomed.
DD.
It's D?
DD one visual mode, like more, or you can use numbers. D1.
Okay.
D5.
Okay. And then how do I change the currently open file? How do I change the file I'm editing? Okay, and I just pressed P there. Vim power user Calvin Deutsch, fine. Lock in. Okay. Okay. There we have it. I moved the struct from the header file to the I was gonna call it the Keter file, but no, that's the C file. Okay, so we're going to make pair clients. I am gonna definitely make a make file. This is annoying. Ooh, not allowed. Why is that not allowed? Redefinition. Originally defined here. Conflicting types. Oh my gosh, it's a disaster. The storage size isn't known. The storage size isn't known. I have not informed the compiler within the header file, and the header file is the only file that is visible to the client file. None of these files know how big struct pair is, right? Only the .c file knows how big struct pair is. So somehow I have to deal with the fact that that has an ambiguous size and therefore can't be placed on the stack because I don't know how big it is, so I can't put it on the stack, right? So how am I going to solve that? Well, this is where we're at right now. This is the storage issue. So we're instead going to use, oh, and we cut it off, right? We have a malloc here, right? That's a malloc of relevant size. What we're going to do instead is we know the size of pointers. So we're not going to pass the struct around directly. We're going to pass around an opaque pointer. What makes it opaque? We don't know what is at that pointer location. What is at that pointer location is defined by the contents of the pair.c file. It is an implementation detail, and there can be different satisfying implementations of the same header file. Okay? I'm calling this pair pointer for now. And let's go through and change these files over. Right, so in client.c, we're going to change this thing from a struct pair to a pair pointer. I think that's all I'm going to do. Then I'm going to nuke it. Oh, and we do have to free at the end. That's true. Okay. Free p. Okay, we're going to save that. We're going to vim pair.h. Okay. And what are we going to do here? We're going to add a type def, and we're going to change the type of something. So we're going to do... This thing is now going to be a pair pointer. Pair pointer is not defined, so we're going to define it right here, and we're going to say type def. Oops. How do you spell type def? Type def struct pair struct. It's currently called a pair struct. No, it's just called a pair. Okay. And I'm going to call that star pair pointer. And that is the same text that is right here. So what is that? Something that is of type struct pair star, the location of a pair. Not the pair itself, the location of the pair. And the description of the location has to be 8 bytes or some fixed number of bytes in size, right? Because everything has to have a fixed description of how large its memory space is, right? So this thing is some fixed known size without us being forced to commit to any particularly size of our pair structure. This means I can now contain large amounts of diagnostic information in there and other features as well. Hey, I'm in visual mode. That's cool. What am I after that? Okay. We'll save that. What are we going to change here? We have to change the return type of noop, okay? So we're going to do, I meant to type 3. No! Undo. Okay. D3E. Undo. Okay, D2E. There we go. This is going to be a pair pointer. It is not going to return a struct pair, P. It is going to return a pair pointer. Pair pointer. That pair pointer P is going to be a pair pointer cast of the malloc. And we're going to malloc what? We're going to malloc enough space for a pair, which is going to be size of struct pair. And that is how big our thing, our structure is, okay? And I think that's what I've done so far. Okay. Now, there's a bunch of these arrows here, and I'm going to motivate what those arrows are by, first I'm just going to save this, and we're going to compile it, and then we're going to see what happens, okay? So, Ooh. Really? What's this? Comma expected before malloc? The type is unknown? Did I spell something wrong? I guess I expected that to work. Unknown type. Name. Is it the order? Okay. Apparently the order you provide things to GCC matters, which I learned right now in front of all of you. Okay. So list your header files first. Okay. So what are the errors? P is a pointer. Did you mean to use arrow? So this dot notation, we have used this dot notation to look up things inside structures by name. P is no longer a structure. It is now the location of a structure. I'm going to show you how to fix this error in line 9 of pair.c. And then we're going to come back and we're going to look at this, and then I'm going to show you another way. Okay, so we're going to vim pair.c. We got an error in line 9. How do I show lines? Set. I don't remember. Doesn't matter. Okay. This P is not a structure. It is the location of a structure. We have to look up where it is. So we use star P. Now, star P.x is actually the information at location P.x. So we have to additionally include parentheses around it like so. I'm going to leave those out for now and show you what the error looks like. Okay, so we're going to save that. We're going to gec. P is a pointer. Same problem is happening, right? This is logically equivalent, and I'm going to show you by using parens, to this statement, and not in insert mode. I'm drawing the same error. P is a pointer, so we cannot apply dot to it. Dot binds more tightly than star. I don't know why that is. That's just how it is. All right. Okay. So the way we fix this is we change where the parens are. I'm going to get rid of this paren and that paren. We're going to move them. And this now, star P, is the structure. Okay? There's an error at line 9. The error at line 9 went away. We fixed the problem. Okay. But this is cumbersome and uggo, right? So instead of serving ugg, we're going to serve shrug, right? And we're going to shrug and we're going to do an arrow. Let's see. So what buttons am I pressing? Like my brain just hit an underscore and I don't know why. Okay, so we're going to use, whoa, oh, I'm not in insert mode. Okay, maybe it's harder to use Vim while you're talking. None of these things happen to me at home. Do any of you use Vim in front of other people? A little bit? Is it harder while you're talking?
Yes, sometimes.
Maybe not.
Be that you're standing up. Keyboard,
That could be true. Yeah, the physicality is interesting. Okay, I'll think about this. I'm going to keep practicing. I was eager to try teaching in Vim this term, and I think it's been a resounding failure, but I bet that's just because I need to get good. I think that's the issue. Okay. What was I going to put here? Y. Okay. There was an error in line 10. Let's see if it goes away. And it is gone. Now all of the errors are in client.c, right? So these are two equivalent formulations and they solve the same problem. And I think I say that much on these various slides, right? So I'm going to fix all of these problems now. Okay. Let's go into client. Is that right? Really? Oh, I thought that would work. Why didn't that work? Let's look at the header file. Okay, and then let's look at the C file. It was my expectation this would be successful. Okay. We cannot access internal fields. Wait. Oh, wait. Is that allowed? Invalid use of the undefined type. Oh, the problem is that my fields are private. Remember? We have not informed anyone of the X and Y locations of anything through our header file. So we can't access things by name. And this is kind of the name problem you asked about earlier, right? We don't actually necessarily care about the names of these things. So what do I have to do to solve this problem? Well, I get to write getter and setters. Oh my gosh, my favorite. Okay, so how am I gonna do this? We'll just write get, I guess. What I write over here? Oh, just set. Okay, let's set some values. Now, when I write a setter method in an object-oriented language, it is a method of some class, and its first argument is self. This is a function, but I'm still going to provide the same first argument, which is the object which I am setting. That object is of type pair pointer. Okay? Then I'm going to accept two values, some integer x and some integer y, and those are the values which I'm going to set. How am I going to set them? Right, we're going to do px equals x, py equals y. Return nothing. And I think that's that. Okay, so we're going to save that. And then we're going to vim client.c. And instead of setting these values here, right, what we're going to do is get rid of those lines, and we're going to set p. Ooh, did I put a... I don't remember what I called it. Anyways, we're going to set p1, 2. And that would be allowed, but I forgot one thing. I wrote set p, oops, in pair.c, but it is still not a public function because it's not defined in the header file. So I'm going to additionally edit the header file to include whatever this thing is. How am I going to do that? I'm going to do pair.h. Let's see. Void set p. Oh, I should have just copied it. Pair pointer p int x int y. I'm going to semicolon terminate my declaration, which is not a definition. I'm going to save. I'm going to compile. No errors, and then it works. And so this is how to implement privacy using header files in the C programming language. I don't know that I would say you should do this, right? But it is possible. Usually I think this is naturally occurring, and it's just simply beneficial we don't have to reason about the internals of something. The classic example of internals that I think you don't want to ever reason about are no one ever wants to think about what printf does. No, man's not found? I don't have... It's not raining men? Okay. Printf is this, like, crazy, chaotic entity that is terrifying and we don't want to think about, and it just happens to work, right? And that's good. That's exactly how we like it. We want to type include standard IO and then just be able to print things. We never want to think about it ever again. And then before we send our code to anyone that we respect, we want to take out all the print statements, right? So that's how I think of this stuff is working. Are we out of time? Yeah, we're pretty much out of time. Yeah. This is the exact interfacing type we used on 496T. We just didn't think about it, right? We weren't using type defs or struct definitions, right? We were just using int stars. All of those uint 80, uint 64T stars should actually be big num t, right? And then it should be user defined how big the big num is, right? That's the only change I'd make. I was going to implement a recursive data structure if we had time, which I don't think is like the best use of our time right now. Any questions today? I feel like I lost all of you, but I was also low energy last night, so I think I might just be out of it this week. Was I as funny as normal?
Yeah.
Okay, that's good. Yeah.
So, but like, if you're giving a pointer to the location of the structure, could they not just like all try and read in a way for however long you think the structure is.
Yeah. I would say this is private and not secure. And I think if I wanted to secure it, the general recommendation is you like just start stacking structures inside of each other. Fundamentally, once you are giving a user access to the heap, nothing is secure anyways, right? So you have to lock things behind. Now, one of the things I would probably do if I were trying to make things secure, so I wrote like a little crypto unit in Python once, and I don't think it was that interesting, so it hasn't persisted into later classes, right? But what you could do is you could base 64 encode everything inside your structure and not document that, right? And then it would be very difficult for someone to determine the encoding type. So because we've taught cryptography this term, right? All of your getter and setter functions could have crypto running inside of them. And that is actually how I would secure things, right? So if we have an encrypted hard drive, we understand it like encrypts and decrypts itself all the time, right? But you can do that with a data structure. It's just like, why would you ever pay that performance cost? But it is possible. So like as an academic exercise, you can think like, oh, I can make a secure int type that RSAs itself, and every operation performed on it, I have to provide a key. I don't know that anyone's ever done that, right? But it is possible. It would make addition very slow, right? Thank you. I'll see you on Thursday. We're doing something cool on Thursday, I would assume. Blockchain, yeah. Stay in school. I used to say don't do drugs. I kind of outgrew that. Drugs are cool. Uh-oh, you're coming for me.
And it like
I need advice saying
it will
at some point.
translate. So if it's
Cool.
like